Alright, so here we are in Chapter 4, still in Chapter 4, Systems of Equations, but now in 4.3, Section 4.3, talking about the addition method. So we're going to talk about the addition method. It's the second method that I recommend using. The first method, 4.1, was graphing, and that we kind of found that it was kind of cumbersome. Not quite so precise either. 4.2 was the substitution method, where we could substitute one value in for x or y into the other equation and kind of solve that way, solve a system for x and y. This second method, which is 4.3, second method that I recommend, either the substitution method or the addition method is what I recommend using to solve a system of equations. So the addition method is going to be pretty straightforward, I think. But like I said, it's going to be the choice of either the substitution method, or the addition method, which is what I recommend using for solving a system of equations, only because these two methods, substitution or addition method, are going to be the most, give you the most accurate measurement, I guess, and most accurate solution. So let's go to the addition method example. So here's basically what we have to solving systems of equations using the addition method. So in order to solve, we talked about graphing, we talked about substitution, and the third way is solving systems of equations using the addition method, sometimes called the elimination method. So like I said, I recommend either the addition method or the substitution method for solving it. When I say on a test or a quiz to please solve this system of equations, it'll be your choice of how to solve it. You can graph it, I don't recommend it. Or you can use the substitution method that we used in 4.2, or you can use the addition method. Whatever you choose is fine, as long as you get an answer and it works for that solution. So for the addition method, here are the steps. Here's the executive summary, borrowed from page 291 in our textbook. So make sure that both equations are in the same format. By that I mean x's in both equations are on the same side of the equal sign. Y's in both equations are on both sides of the equal sign. Numbers in both equations are on the same side of the equal sign in both equations. So in other words, x's always have to be on the left, y's always have to be on the left, numbers always have to be on the right, something like that. That's what I'm talking about for the same format. Step 2 is clear fractions, if you don't want to work with fractions. If you want to work with fractions, go ahead and do it. But clear fractions by multiplying by a common denominator to get rid of that fraction to make it a whole number. Step number 3 is multiply one or both equations so that, and this is probably the heart of the matter, multiply one or both equations so that the coefficients, the numbers in front of the variables of one variable, either the x or the y, are opposite. Opposite means one's positive, one's negative, but the same value. So one could be positive 5, one could be negative 5, so that when you add them up using the addition method, they will go away. So that's step number 3. Step number 4 is add both equations. And when you add both equations, because you've made the coefficients of one of the variables opposite, when you add them up, that will eliminate one variable. So step number 5 then, after you've eliminated one variable by adding them up, then the remaining equation, added equation, will have just one variable, and you solve for that variable. You'll have an x equals or a y equals some number, and then just like, well, let's see, step 5, 6, 7, and 8 are pretty much like the substitution method. Remaining equation has one variable, solve for a variable. Take that variable value back into step 5 take that value that you found in step 5, put it back into one of the original equations, and you solve for the other variable. And then you check your solution. So let's see what that looks like. Here's an example. Solve this system using the addition method. Alright, well, step number 1 is let's see, make sure that both equations are in the same format. And I hope you've printed this out because I didn't do a double slide of this one. But make sure that they're both in the same format. In both equations, the red and the green, x is on the left of the equation, or the equal sign. So that's good. Y is on the left side in both equations of the equal sign. All right, well, that's good. Numbers on the right side in both equations. All right, so that means they're in the same format. Now, step number 2 says clear fractions. There's no fractions to clear out. Step number 3 is multiply 1, either the red or the green equation, to cancel to get the numbers in front of the variables, the coefficients, opposite. Well, we already have that. Here's a positive 1 here. Here's a negative 1 here. Remember, that's an unwritten number. It's a positive 1 here and a negative 1 there. We already have something that's set up so we don't have to multiply anything. So step number 4 is just add the equations. So here we're going to add these equations, add the red and the green. X plus x is 1x plus 1x is 2x. Plus 1y minus 1y adds up to 0. And I'll just put it down as plus 0 just for edification purposes. I would not usually write down that plus 0, but just because we're adding these up to make sure that's equal to 0, I'm writing it down for that reason. Now we add the minus 2 and the minus 6 to get minus 8, or negative 8. And we've got an equation in blue with one variable and one unknown, and we're okay. So now we just solve for that variable. We can say that it's 2x equals negative 8 just for simplification purposes. Divide by 2 to get just one x on the left. 2 divided by 2 is 1. X equals negative 8 divided by 2 is negative 4. And there is part of our solution. Remember, if it says solve, it says tell me what x and y are, because we've got a system of equations. System means we've got an x and a y. So don't just stop here. Now we take our x equals negative 4 and plug it in any of these equations. I suppose we could take it into the green equation and say, all right, well, I'm going to start with my x minus y equals negative 6. Plug in my x equals negative 4. Negative 4 minus y equals negative 6. And add 4 to the left, add 4 to the right, so we can just isolate the y. Negative y equals negative 6 plus 4, negative 2. Divide by negative 1, divide by negative 1, and negative 1, unwritten 1. Negative 1 divided by negative 1 is positive 1. Y equals negative 2 divided by positive 1, or sorry, negative 2 divided by negative 1 is positive 2. I'll just write down 2, and there's our solution. Y equals 2, x equals negative 4. Sounds like a decent solution. So we can just, in fact, we can double check and say, well, let's go back and plug x and y back into these equations. X is negative 4 plus 2 is negative 2. That one checks out. X is negative 4 minus 2 is negative 6, and that one checks out. So we've double checked just by plugging in mentally the values there, and we're all set. So that one is our first example of just simply using the addition method to solve a system of equations.